Alright, so in today's video, we're going to walk through a step-by-step process for solving organic chemistry reactions. This method is perfect for your MCAT prep or general studies, and will help you tackle even the most complex reactions. By breaking it down systematically, you'll find organic chemistry much easier to understand. So, let's dive right in. The first and arguably most important step is to know your nomenclature. You need to be able to identify which compounds are being referred to, whether by their IUPAC names or common names. If you're still having trouble with naming compounds, now's the time to our nomenclature video. For instance, knowing that ethyl acetate and methyl ethanoate refer to the same molecule can prevent you from making avoidable mistakes during exams. Alright, now it's time to identify the functional groups in the molecules. Are we dealing with alcohols, carboxylic acids, amines, or maybe esters? This is critical because functional groups determine how a molecule will behave during a reaction. Ask yourself, are these groups acidic or basic? Are there any nucleophiles, electrophiles, or leaving groups present? Recognizing functional groups will help you anticipate what types of reactions are possible. Once the functional groups are identified, turn your attention to the reagents. Are they acidic or basic? Are they strong oxidizing or reducing agents? For example, LiAlH4 is a very strong reducing agent, while PCC is a milder oxidizing agent that stops at an aldehyde instead of converting it all the way to a carboxylic acid. Now, move on to the most reactive functional group. Generally, more oxidized carbons are more reactive, particularly toward nucleophiles or electrophiles. For example, carbonyl carbons in ketones or aldehydes are highly electrophilic, making them prime targets for nucleophilic attack. Watch out for protecting groups that might be shielding a functional group from reacting. This step is essential for determining which parts of the molecule will react first. In this step, figure out what happens first. If there's an acid or base involved, the first step might be protonation or deprotonation. If a nucleophile is present, it might attack an electrophile right away. For example, in a reaction involving LiAlH4, the carbonyl group of an ester will be reduced to an alcohol. By identifying the first step, you can predict how the rest of the reaction will unfold. Finally, consider stereoselectivity. If the reaction yields multiple products, which one will be the major product? Typically, the product with less strain and greater stability will dominate. For example, conjugated systems are more stable and thus more likely to form. Alright, so those are the 6 key steps to problem solving in organic chemistry. 1. Know your nomenclature. 2. Identify the functional groups. 3. Identify the reagents. 4. Identify the most reactive functional group. 5. Identify the first step of the reaction. 6. Consider stereoselectivity. Follow this method to systematically approach and solve organic chemistry reactions with confidence. If you enjoyed this video, please give it a thumbs up, share it with your friends, and don't forget to subscribe for more in-depth chemistry content. Also, make sure to check out King of the Curve for more interactive learning tools and resources to enhance your studies. Thank you for watching, and good luck with your chemistry prep.